Welcome to this new video. In this video, we are going to understand about computer networks. Whether you have some previous knowledge of computer networks or you are completely new to this subject, I hope this video will find a best place in your heart. So without further ado, let's start with this series. At first, we will learn about what is actually computer network and what is internet after all. So what is a computer network? A computer network is a group of computers which are connected with each other, either some form of wire or with some form of wireless medium, and they can share data between themselves and also interact with each other. In fact, to share data between themselves. So this is about computer network. So if any two devices or any three devices are connected to each other so that they can share data between themselves and communicate with each other, they form a computer network. See, it is not always that it has to be a computer. It can be your mobile phone, your router, your laptop. Yes, they do form a computer network. It can be a mobile phone with your Bluetooth headset. Yes, these all are an example of computer network, but it is not internet. So what is internet after all? Internet is nothing. Internet, if you break the term into two parts, that is inter and net, and you expand inter to interconnected and net to network, you get the full meaning of the term. It is interconnected network. So when many computer networks are connected to each other so that all the networks and all the devices in a network can communicate with each other and share data between themselves, they form a internet. So you can call internet as a collection of multiple or numerous number of computer networks. So this was about the computer networks and this was about the internet. Now let's understand about how many types of data communication there can be between two devices. See, what is data communication? When two devices share data between themselves, it is some form of data communication, right? Now this data communication can be of three types. One is simplex, one is half-duplex, one is full-duplex. Now what is simplex type of communication? Simplex type of communication occurs when two of the devices are sharing data, but only one device is able to share the or transfer the data to another device. That means that if two hosts are there, only one host can transfer data from it to the other device. Means you can take the example of the radio stations, right? When news is transferred over the radio station or say in a television, it is one-way communication, right? We cannot reply back to the news or any information that is being shared. So it is like the only one host can share data to the other host, and yes, the other host cannot reply back. So this is an example of the simplex communication, wherein only one host is able to share the data with the other host. Now comes a little improvised version of the simplex communication, which is the half-duplex. Now what happens in half-duplex is, in half-duplex, both the devices or the host can share data between themselves, but the fallacy is that only one device can send data at the same time. That means if two devices have the need to share some sort of data, it is only one device which can send data at a time. Both the devices cannot send data at the same time simultaneously. So this was about the half-duplex. Okay, you can call it as a two-way street where one device is sending the message and the other is also sending the message, but not at the same time. For example, in the walkie-talkie you can see, when you are speaking in the walkie-talkie you cannot hear, and when you are hearing in walkie-talkie you cannot speak. So this was the example of the half-duplex communication. Next comes third type, which is the most improvised and the most advanced type of communication which we use in today's world, is the full-duplex communication. Now what happens in full-duplex communication is both the devices or the host can send data between themselves and they can interact with themselves simultaneously at the same point of time. This is the mobile networks that we use in today's world. It is a full-duplex communication where both the host can send and receive data simultaneously at the same time. Alright, this was about the full-duplex communication. Now that we are able to understand about the types of communication, now let us understand how many kinds of networks can be there. Now depending upon the size of the network, networks can be classified into four categories. Okay, depending upon the size. That means what is the range of the network? Okay, means in meters. So based on this, the networks can be classified into four types. One is the personal area network, next is the local area network, third is metropolitan area network, and the fourth one is the wide area network. So what is the differences between these four categories? See, at the first we have the PAN or the personalized area network. Now what is the meaning of this? Personalized area network allows, or you can say personal area network is a type of network which is used to connect devices which is surrounding a particular person. What does this mean? Suppose I have my mobile, it is connected to my laptop, my mobile connected to my Bluetooth headset, my mobile connected to my smartwatch. What is the common thing in between them? The common thing is that the range between these things can be up to few meters, that is in between a room, right? So this is the personal area network which is used to connect devices surrounding a user. So the range of this personal area network can be extended to few meters and also within a room. So this is the personal area network, which is a very small network. And on the other hand, the mode of communication between the devices in a personal area network can be wired and wireless. So this was about the personalized area network or personal area network. That's it. Now, after personal area network, when the range of network increases a bit, we come to the local area network. Now, what is local area network? Local area network or LAN is used to connect devices which is present in the office campus, or you can say your college campus, right? So what happens? Here the range of the network ranges from few meters to few kilometers, right? You can take the example of the computer labs in your college campuses, right? It's very large and spread over large geography within few kilometers, and they are all connected by some Ethernet cable or the local area network, right? So this was a local area network where the size of the network has increased from few meters to few kilometers. This is the local area network. And here also the mode of communication between the devices can be through wired and also wireless, that is the Wi-Fi which we have. And also it can offer a great speed from 10 to 100 Mbps. We all know that using the fiber optics cable or the CAT cable which we have in today's world. So this was about the local area network, where the size of the network can be from few meters to few kilometers, used for connecting devices which is present in an office campus or you can say a college campus. So this was about the local area network. After the local area network, we come across the MAN or the metropolitan area network. Now what happens in a metropolitan area network is it is useful for connecting devices present in a large cities where the users or the clients have a need of high speed internet access throughout the day or throughout the year, right? So metropolitan area network is, you can take the example of your ISPN, like the internet service provided in a local area. They all use the MAN or the metropolitan area network, which is useful for connecting or providing high speed internet access across a large city. This is an example of the MAN. After the MAN, we come across a large type of network which is the WAN or the wide area network. The wide area network consists of is a network which is useful for connecting devices in a whole country or the whole world. Suppose the internet is an example of the WAN or the wide area network, which is useful for connecting devices in a large, you can say large geographical area, for example like a country or a whole world. Okay, the World Wide Web, www, which we write in front of the URL, is an example of the wide area network, which is useful for connecting devices in large geographies of land. Okay, this was about the type of network based on the size. Okay, now let us understand in how many ways can we connect two devices in a network. Now two devices in a network can be connected in two ways. One is point-to-point connection and another one is the multi-point connection. Now what happens in a point-to-point connection? In point-to-point connection, as you can see, two devices share a link which is used completely for exchange of data between these two devices. You cannot see a third device interfering in this connection. That means every device or between two devices there is a dedicated link for sharing information between the two devices. This is the example of the point-to-point connection, and you can say that the entire capacity of the link or the channel is utilized for sharing data between two devices. After this, we have the multi-point connection, which is most common in these days. In this, multiple devices in a network are using or connected using a common link. This is called a multi-point connection, which is just the opposite of the point-to-point connection. So you can say that in multi-point connection, the channel capacity or the capacity of the channel is shared and used temporarily between the two devices or the connected devices in a network. That means the wire cannot be, or the channel cannot be used at its full capacity at a time, because it is always shared between the multiple devices. However, we do get the best speed out of this, and this is the most economic one which you can afford. So this was the example of the multi-point connection. Now, using this type of connection between two devices, there are many ways in how can we connect two devices in a network, right? So here comes the importance of network topology. What is network topology? Network topology lays down the way in which two devices or multiple devices in a network can be connected together efficiently so that they can exchange or transfer data between themselves. So you can say, in other words, it is the geometric relationship between the devices in a network. Okay, this was about the network topology. Now there are various types of network topology based on the arrangement of devices in the network. First comes the mesh topology. Following this, we have the star topology, then the bus topology, and at last we have the ring topology. And there are also many other types of topology, but these are the important ones. Okay. Now, what is mesh topology? In mesh topology, as you can see from the image, devices connected to each other using a point-to-point connection through dedicated link between each other. You can see that every devices in this network have a dedicated point-to-point connection with each other. So you can say if there are n devices, then there are n into n minus 1 by 2 links between them. So as a problem of this, there can be a huge amount of wire load, or you can say wire pressure which you have to handle, and wire management we have to do. But on the other hand, this is costly also, and the advantage of this is the fault isolation and the identification is very easy in this, because if one link is not working, the entire network is not affected because the other links keep on working. So you can say that this is a very robust kind of topology. Okay, this was about the mesh topology, where a lot of wire threshold you have to handle. After this, we have the star topology. Star topology is also using a point-to-point connection, but in this case, all the devices are connected to a central controller, which is also called the hub. So every devices in the star topology is connected to the central controller of the hub to share information between themselves. So you can say that if one device has stopped working, the other devices in the network are still functional and they can share data between themselves. But on the other hand, if the central controller of the hub stops working, the other devices are sacrificed, or the network is sacrificed, because the hub is acting as a central controller. If you want to send data from one computer to another, then it has to, or compulsorily has to, pass through this hub to move to the destination device. So this was about the star topology. This is also robust, but if the central controller or the hub stops working, the entire topology or the network is sacrificed. After this, we have the bus topology, which is commonly used in the office campuses and the college campuses as well. So what happens is this: in this, every devices are connected by a multi-point connection to a backbone cable or the bus cable through the data links and taps, which is the connector between the device and the main backbone cable. So in other words, this is a multi-point connection, and you know that the entire capacity of the channel cannot be utilized at the same time. However, it is made optimized so that it can get or produce an optimal speed to all the devices, right? So on the other hand, if the backbone cable stops working, the entire network has to become sacrificed. So this is the example of the bus topology, where all the devices are connected to the central backbone cable using the data links and taps. So this was about the bus topology. After the bus topology, we come to a very interesting type of topology, which is the ring topology. In ring topology, all the devices are connected to the adjacent devices using the point-to-point connection, and hence they form a ring-like structure. As you can see from the diagram, all the devices are connected to the adjacent devices computers using a point-to-point connection, but in a circular manner. Okay, so if I want to pass some information from computer 1 to computer 6, say, it has to pass in a clockwise direction to computer 2, 3, 4, 5, and then it can reach to 6. But on the other hand, if the ring is broken, the data cannot reach, and this is a major flaw of this type of ring topology. Now, after this type of topology understanding, we will now understand the OSI model, which is the open system of intercommunication model, based on which the modern day internet works. The modern day internet do not use the OSI model, but it uses the TCP/IP model, which is inspired from the OSI model, or the open system of intercommunication model. So based on the open system of intercommunication model, it provides us with 7 layers. Okay, this 7 layers provides a medium so that the data can travel efficiently from one device to another. When you are passing some sort of data from one device to another device or through some internet, all your data has to pass these 4 layers or 7 layers to reach to other device effectively. So how does this model works? OSI model gives us 7 layers. The first layer is the application layer, second comes the presentation layer, third comes the session layer, followed by this we have the transport layer, then network layer, data link layer, and at last we have the physical layer. So what happens in these 7 layers? Let us try to understand now. First we have the application layer. All your web browsers, web clients, URL documents, or the websites come under this application layer. All your HTTP protocol, HTTPS protocol, FTP protocol, or your email protocol, all these types of protocol comes in the application layer. It is the topmost layer of the OSI model, and it is generally used to provide an interface to the client who is interacting with the network. This was the OSI application layer of the OSI model. Okay, after this we have the next layer, which is the presentation layer. Now, while your data passes through all these mediums, it is needed, or it is important for the data to be compressed and it to be encrypted and translated, so that any other person or malicious attack do not happen on your data and your data is not corrupted. So for that, your data has to be encapsulated, compressed, and translated, right? So this thing or this functionality is done by the presentation layer. So what is the main functionality of the presentation layer? It prevents the malicious attack to the data by encapsulating the data, translating the data, and also compressing the data so that it can be passed very fast to the network. After this, the presentation layer, we have the session layer. To understand the session layer, let us take the example of the banking websites like SBI, ICICI. What happens there is after 30 minutes of inactivity, you have to log in again and your session gets expired. So this thing is managed by the session layer, whose main functionality is to create and terminate sessions for security purpose. After this comes the very important layer, which is the transport layer. What happens in transport layer is its main functionality is to provide the source to destination delivery of the message, and how the message will be delivered, whether it is delivered properly or not, and whether the message is delivered accurately or not. That means there can be loss of the message, right? So these things are managed by the transport layer. We will learn about transport layer in some other video, but at this point of time, you have to keep in mind that its main role is to process delivery of the message. Okay, now after the transport layer, we have the network layer. At this point of time, the network layer provides you the IP address, which is very essential for identifying your device in your network. Suppose you have 10 devices connected to your router. So how will a router be able to recognize your device? Your router cannot see your model of your mobile phone, right? So the router identifies each device by using a IP address. This IP address is provided by the network layer for identification. So this was about the network layer. After the network layer, we have the data link layer, which provides us the MAC address, or you can say the physical address, for transferring the data from one node to another. Now, another major functionality of the data link layer is that it has various protocol which lays down how the channel will be utilized between two devices in a network. There are various protocol in this. There is CSMA-CA, there is CSMA-CDMA, right? There are various protocols. There is Aloha also, slotted Aloha also. So this protocols determine how the channel will be utilized between two devices who are intending to communicate in a network. So this was about the data link layer. After the data link layer, we come to the last layer, which is the physical layer of the OSI model. So physical layer is actually consisting of the CAT cables or the coaxial cables or the optical fiber, which are intended to provide physical connectivity between the two devices who are intended to communicate in a network. So this was about the 7 layers of the OSI model. So I hope you have liked this video. Remember that OSI model is not actually implemented practically. However, the TCP/IP model which we use in today's world is inspired from the OSI model. So this was about the 7 layers of the OSI model. I hope you have liked this video. Keep watching, and if you have not understood anything, you can put down a comment in the video description and I will be happy to answer them. So thanks for watching. See you in the next video.